Dart School presents multiplying and dividing decimals. There's something interesting about multiplying or dividing any number with a power of 10. Let's say you want to multiply the number 1234, just writing down 1, 2, 3, 4 in that order, 0.5678 times 10. The answer to this multiplication is going to be the same digits in that same order, only the decimal point moved one place over to the right. So the answer will be 12,345.678. And then when you multiply this number with 100, the decimal point moves two places over to the right. So we have 1, 2, 3, 4, 5, 6 times 7, 8. And when you multiply the same number with 1000, probably you guessed it right, move the decimal point three places over to the right. That makes it 1, 2, 3, 4, 5, 6, 7.8. And you do just the opposite when dividing this number with powers of 10. So if you were to divide 1, 2, 3, 4, 0.5678 with 10, the answer would be one place over to the left this time, the decimal point, 123 point, all the rest, 4, 5, 6, 7, 8. If you want to divide that with 100, you have two places over to the left, which makes it 12.345678, and so on. And just in case you're running out of digits in a multiplication or a division, you can feel free to add zeros, because zeros at the beginning of a number or at the end of a decimal number don't change the number. It's still the same number. For example, if you were to do, let's say, 1.6 times 100, you know that you need to move the decimal point two places over to the right because you're multiplying with 100, and it seems that there is only one digit. So what you do? Well, you just add 10 to the end. And you can do that. 1.6 is the same as 1.60. And therefore, once you move the decimal point two places over to the right, the answer is 160. Point what? 0, obviously. So it's the integer number 160. Similarly, if you are dividing, let's say, 8.7 with 1000, the decimal point should move three places over to the left, but we only have one place. We can always rewrite this as 008.7. It's still the same number. And therefore, if you move this three places over to the left, you have 0 point, the decimal point is over here. If there is nothing before the decimal point, it means there's a 0. So we have 0.0087. 0087. And we can actually make use of this useful property to multiply and divide decimal numbers just as you would divide or multiply normal numbers, I mean integers. Let's say you want to multiply 2.4 with 3.1. When you do the actual multiplication, you just ignore the decimal points. So it's as if you're multiplying the number 24 with 31. And you know how to do that. 1 times 4 is 4 and 1 times 2 is 2. Put a 0 on the next line. 3 times 4 is 12. Write down a 2, carry the 1. 3 times 2 is 6. 6 plus 1 is 7. And then add them up. We have a 4, we have a 4, and we have a 7. So 24 times 31 is 744. No problem with that. But then what's the relationship between 24 times 31, the one that we did, and 2.4 times 3.1, the one that we need? Well, 2.4 is nothing but 24 divided with 10, and 3.1 is nothing but 31 divided with 10. So effectively, we are multiplying 24 with 31 and dividing that answer with 100. So 744 needs to be divided with 100. The decimal point needs to move 2 places over to the left from where it is on 744. Now on 744, obviously the decimal point is right in the end. So the answer is going to be 1, 2 places over to the left. The answer to 2.4 times 3.1 is 7.44. And what would the answer to, let's say, 0.24 times 3.1 be? Once again, you do the multiplication without the decimal points. So you do 24 times 31. 0.24 without the decimal point looks like 024. And the 0 at the beginning of a number doesn't count. So you could still use a 24 in place of that and a 31 in place of this. But then 0.24 is nothing but 24 divided with 100. So if you're moving the decimal point from the end of the number, the decimal point is right in the end for 24 and for that matter any other integer number. If you're moving it 2 places over to the left, that means you're dividing that number with 100. And for 31, I've kept the same number, 3.1. So that's 31 divided with 10. And therefore, the answer to the multiplication is the product of 24 and 31 divided with the product of 10 and 100, which is 1000. Which means this time, you move the decimal point 3 places over to the left. So this is going to be equal to 0.744. The number of digits after the decimal point on the answer is going to be equal to the sum of the number of digits after the decimal point for each of the numbers that you're multiplying. So what I mean is, there was 1 digit after the decimal point on 2.4, 1 here, and 1 digit for 3.1. So that's 2 in all. The sum is 2. You put your decimal point on the answer in such a way that you have 2 digits after the decimal point. Look at this. There are 2 digits after the decimal point on one of the numbers you are multiplying and 1 digit on this one, the other one. Therefore, there are 3 digits after the decimal point on the product. So the bottom line is, you do the multiplication without bothering about the decimal points, and then in the end, just apply this rule. And then can we use the same rule on division? Of course we can, because multiplication and division are related. So if you were to divide, let's say this number, if you were to divide 0.744 with one of the other 2 numbers, let's say 0.24, if you were to do this division, the answer would be the other factor in the multiplication sentence. So you would expect a 3.1 here, because this times this is equal to this. And remember, in division of decimals, there's no remainder. But then the number of digits after the decimal point on this one, which is 2, plus the number of digits after the decimal point on this one, which is 1, has to add up to the number of digits after the decimal point on this one, which is 3. We have already learned that in this and this example, right? Now this time we want to figure this out, and that's obviously is equal to the number of digits after the decimal point on the dividend minus the number of digits after the decimal point on the divisor. 3 minus 2 is 1. That's one way of finding that out. But if you want to make it even simpler, typically you want to make this a 0. I'll tell you how in a moment. But if you make this a 0, that would mean that whatever the number of digits after the decimal point is on the dividend minus 0, so minus 0 doesn't make any difference, is the same as the number of digits after the decimal point on the quotient at the top. So if this were to be a 3 and this were to be a 0, then this would also be a 3. Now how do you change this to a 0? It's pretty simple. You multiply this with a certain power of 10 so that the decimal point moves right in the end. The number changes to an integer. In this case, Obviously, because you need to move it 2 places over to the right, you will multiply this with 100. But if you're doing this, if you're multiplying the divisor with 100, you also need to multiply the dividend with 100. Otherwise, the whole problem changes. So this division problem out here is exactly the same as the division problem. Move this 2 places over to the right, multiply with 100. So we have 74.4 divided with 2 places over to the right, 24. Once again, the idea was to make this one a 0, no digit after the decimal point. There's only one digit after the decimal point. Therefore, the answer or the quotient at the top will also have one single digit after the decimal point. That lets you put the decimal point right above where it is on the dividend. So you can pretty much go on with the normal division, ignoring the decimal point. 744 divided with 24, and you get 31. And when you get the 31, the decimal point is just above where it is, like I said, on the dividend. Therefore, that becomes a 3.1. Let's try another example. Let's say we want to divide the number 1.43 with 1.3. Like I said, not the only idea, but a good idea is to move this decimal point right in the end. Therefore, we multiply this with 10. And if we do that, we need to multiply this number with 10 as well. And therefore, the whole problem changes to 14.3 divided by 13. You can think of it as 143 divided with 13. Just keep in mind that the decimal point on the quotient will be right above where it is on the dividend. So 13 can go into 1, and 13 times 1 is 13. Subtract 14 minus 13 is 1. Bring the 3 down. 13 times 1 is 13. No remainder. Therefore, the answer to this division is 1.1.